Let's discuss kinematics in one dimension. So, kinematics deals with the concepts that are needed to describe motion. So, dito sa kinematics, we'll just describe those concepts na magdi-describe lang sa motion, pero hindi pa kasama doon ang force. Because if we will already be dealing with the force that causes that motion, we will now be dealing with dynamics, because dynamics deals with the effect that forces have on motion. So imagine a moving object. If we'll just have to describe the position of the object, the speed of the object, gaano ito kabilis, the acceleration of the object, there we study kinematics. Pero pag pinag-aralan na natin kung, for example, gaano kalakas yung force na kailangan para ma-move ang isang object, or gaano kalakas yung in-apply na force kaya dumating sa ganitong distance ang isang object, yun ay nasa dynamics na. But together, kinematics and dynamics form the branch of physics known as mechanics. So I think, I don't know if you'll still reach mechanics, but for this subject, we'll just be studying kinematics and dynamics. Okay, so let us go to the concept of displacement. So from our previous lessons, displacement is a vector quantity. So when we say it's a vector quantity, and vector quantity, according to our previous lesson, are quantities that are not just concerned with magnitude, but also concerned with direction. Okay, because displacement is a vector quantity. So, kinukonsider natin ngayon ang direction. Kaya nga on our previous lesson, kapag pinag-uusapan natin ang vector, nag-a-assign tayo ngayon ng convention, ng sign convention. If it is positive or negative, depende sa direction. So, going to the right or east is positive, going to the left or going west is negative, going up or north is positive, and going down or south is negative. Okay, so like for example, in this figure, if you'll try to look at the car, so here's displacement. Displacement is a vector quantity that describes how far now an object relative to its original position. So, ang displacement, dinidescribe niya kung gaano na talaga kalayo ang object mula sa original position at saang direction ito. Hindi lang yung distansya, kundi pati yung direction, saan siya relative to the starting point. So, like for example, in this figure, look at the car. Dito sa figure na to, if we'll be looking at this figure, so the car has an initial position x sub 0. Yung initial position niya ay ito. Sabihin natin, ito yung initial position niya. So from this, hanggang nag-move siya into this position. So the initial position and x is the final position. Now we are talking now with displacement. When we talk about displacement, again, this is a change in position with respect to your original position, dun sa initial position mo. Okay, so delta x is equal to x minus x sub 0. This now is the equation of our displacement, where this triangle, delta, ibig sabihin yan, change. Okay, delta means change. Kapag nakita kayo ng triangle, it's a delta or it means change. Okay, so the change in position, delta x, is equal to x minus x sub 0. So like for example, if we are to get the position or the displacement of this car from its initial position going to the final position, sabi niya, ang initial position niya ay 2 meters from this point, no? Mula doon sa sabi nating 0 at nandito yung car na una, initial position, which is 2 meters. And then the final position of the car at this point is 7 meters. Now, if we are to compute the displacement or the change in position of the car, then we need to use this equation delta x. Delta x is x minus x sub 0, the initial, is equal to 7 minus 2 meters. So the answer would be 5 meters. If we are to describe its position, you'll notice that 7 and 2 meters are positive. Why? Because these vectors, both points going to the right, are going to the east position. If you'll try to look at the figure, this is going to the right, and this is also going to the right position. That is why it's both positive. So the answer is 5 meters. Okay, so this is from this point going to right. But if we are to measure, from this point going to the left, okay, the displacement will become negative because again, our sign convention, going to the right is positive and going to the left is negative. So depende yun sa initial position nyo at kung saan papunta yung object. Okay? So dito naman, for example, yung initial position ng initial position 2 meters. Then, initial position ay 7 meters. So, dito siya, 7 meters. Tapos, pumunta siya dito. From this position. So, delta x, x sub 0. If you try to look at our, okay, so this is still 7 meters going to the right, also going to the right, but the measurement ay galing sa kaliwa. So dito, measure niya lang mula dito sa point na to, papunta dito. Kaya ito ay negative 5 meters kasi ito yung measure niya. Ito naman yung measurement mula sa at this starting point going to the right. Okay? So, the positive and the negative sign just denotes the direction. So, halimbawa naman ito, ang initial position niya ay negative 2 meters. Ibig sabihin, kung ito yung starting point, negative 2 meters, ito yon. Dito siya nagsimula. Then, meron siyang going to the right na 5 meters. At meron naman siya dito negative 2 meters. Now, if we are to measure, for example, from this point going down to this point, ilan na yung change in position na yon. So, delta x, sabi dito, ito yung equation, x minus x sub 0. Now, the vector 5.0 meters, the final position, then minus x sub 0, negative 2, 0. That's why this will become 5.0 minus 2.0. This will become plus, this will become 5 plus 2, negative, negative, equals 7 meters. That is why if we are to describe the difference of their position from this point hanggang dito, Ito ay 7 meters. Now, let us move on to speed and velocity. So, average speed is the distance traveled divided by the time required to cover the distance. Okay, so average speed is the distance over the elapsed time. The SI units for speed is meters per second. So, sabi natin, no, from our previous lesson, speed is a scalar quantity, while velocity is a vector quantity. So if we are talking about speed, we are just talking about the magnitude. Okay? Yung magnitude lang pinag-uusapan natin, hindi pa yung direction. Pag pinag-usapan na natin at kinonsider na natin yung direction niya, doon nagiging velocity na siya. So if average speed, parang rate lang ito. Anong ibig sabihin ng rate? Yung rate ng pag-change, yung distansya na nako-cover niya at a given period of time during the elapsed time. So like for example, in this problem, the distance being run by a jogger. So we are asked to how far does a jogger run in 1.5 hours or 5,400 seconds if his average speed is 3.22 meters per second. Okay, so if we are to ask for the average speed, so sabi natin, speed is distance over time. Okay, let us first denote speed as S and velocity as V. Since we are just talking about speed, then let's have S being equal to our speed, D for our distance, and T for our time. So S is equal to D over T. Now we are being asked to find the distance. By cross multiplication, we can derive the equation for D. D is equal to S times T, where S is equal to the average speed is 3.22, or this is the speed is 3.22 meters per second multiplied by 1.5 hours is 5,400 seconds. So, may typo error pala dito. This is 3.22. Let us compute for the distance traveled by this jogger. So 3.22 times 5,400. This is equal to 17,388. The distance is 17,388 meters. Okay, so this is for the speed, okay, of the jogger. Now let us move to velocity. Again, speed and velocity, they seem almost the same. It's just that if speed is scalar, velocity is vector. Ibig sabihin, yung velocity, kino-consider na natin ngayon ang direction. If we are considering direction, then hindi na yung distance ang i-consider natin, kundi yung displacement. Kasi yun din yung pinagkaiba, according to our previous lesson, yun din ang pinagkaiba ng distance and displacement. Distance is scalar, displacement is vector. That is why the average velocity is the displacement divided by the elapsed time. Okay, so this is for average velocity. Now, average velocity is displacement. According to our equation earlier, displacement is delta x, where x is delta x is x minus x sub 0. The final position minus the initial position. The elapsed time also is equal to delta t. Ibig sabihin, change in time, where t is t minus t sub 0. T is the time where the object reaches the final position, and t sub 0 is the time nung naandun siya sa initial position. Okay, so this is now our equation for velocity. Okay, so alam natin na change yan. That is why kapag binigay na itong mga magnitude ng change at magnitude ng time, na simplify natin ang equation na yan, that v is equal to x over t. Kapag ang ibinigay sa problem ay yung magnitude na ng change. Okay? Para mas madali din ang ating convention pag-determine ng direction ng motion, itong x ginagamit natin kapag ang object, ito ginagamit natin to na x, kapag ang object ay moving horizontally. Para lang ma-determine natin na ang object ay moving horizontal. Kapag vertical naman, gagawin lang natin ang equation na v is equal to y over t. Para naman ma-determine natin kung yung object ay moving horizontal or vertical. So, ito ay for vertical motion. Okay? So, ganun lang. Para mas madali yung pag-analyze natin later on kapag nakaka-encounter tayo ng mga problem. So, like for example, in this example number 2, the world's fastest jet engine. Okay, so let us try to compute for this example number 2. Okay, so from example number 2, the world's largest, fastest jet engine car. So Andy Green, in the car Thrust SSC, set a world record of 341.1 meters per second in 1997. To establish such a record, the driver makes 2 runs through the course, 1 in each direction, to nullify wind effects. So from the data, determine the average velocity for each run. Okay, so parang ito yung data, no? So sabi doon, tinest itong Thrust SSC that in the time of 1997, this was the fastest car, no, existing. So to just eliminate the effect of wind or air resistance, nag-travel yung Thrust SSC first going right. Okay, then record nila yung time, and to nullify the effect of wind, nag-travel naman siya from right going to left. Okay, so ito yung first data niya. Nung going to right at time 0 seconds to start, at a with a displacement of 1,609 meters, natapos niya yon in 4.74 seconds. Okay? Habang yung nung pabalik naman niya, dito naman siya nagsimula sa kanan, going to the left. Of course, the displacement is negative 1,609 because, again, we are now considering the direction. And the time is 4.695 seconds. Okay, so ito yung pinagkaiba, yung time nila. Okay, so going to right, 4.74, going left is 4.695. Now, we are being asked to find the average velocity of this run. Now, how can we find the average velocity? Okay, so sabi dito, based doon sa data na binigay sa atin, if we are to find for the velocity of each run, tignan muna natin yung each run. The velocity for going to the right the velocity of thrust SSC, because we are asked to find the data, determine the average velocity for each run. So for each run, ito yung velocity going to the right. Ito naman yung going to the left. So the displacement is positive 1,609 meters divided by 4.74. So check natin kasi baka may typo ulit. We have 1,609 divided by 4.74 seconds. Okay, this is 339.45. Positive because it is going to the right. So 339.45 or approximately 339.5 meters per second. So going to the left, okay, 1,609 meters divided by 4.695 seconds. This is negative 1,609 because from right going to the left ito. Okay, so negative 1,609 divided by 4.695. The answer would be negative 342.7050, so on and so forth. So this is approximately negative 342.7 meters per second. Pero kung titignan talaga natin, kasi ang pinahanap sa atin ay yung both from the data determine the average velocity for each run. Ibig sabihin, yung going to the right and going to the left. Pero kung ang hinahanap talaga sa atin ay yung velocity, yung average velocity ng thrust SSC, para makita talaga natin, no, inalify natin yung effect ng wind, i-average lang natin itong dalawang nakuha na value. So, ibig sabihin, i-disregard natin kung going right siya or going left. Kasi itong negative, ibig sabihin lang yan ay direction. I-average natin itong dalawang values na to. I-neglect muna natin ang direction. So, if we are to average these two, 339.5 plus 342.7 divided by 2, of course. So, the average is 341.1 meters per second for both run na yon. Kumbaga, regardless ng direction, may it be going to the right or to the left, kaya nga di na tayo naglagay ng positive or negative kasi average na to nung dalawa. So, yun na yung natin, average nung both run. So, it's 341.1 meters per second. Pero kung tulad sa problem, ang hinahanap, each run, then we need to consider going to the right as positive and going to the left as negative. So, if this is the data, for example, masasabi natin na meron ng effect yung hangin. Okay, so saan nagbubulo yung hangin, for example, kung ganito yung data. So, going to the right, ito yung speed niya. Going to the left, ito din yung speed niya. So, mas mabilis yung going to the left, 342.7 meters per second. So, we can say, dahil mas mabagal dito, yung wind ay going on this direction. Kaya naman nung going to the right, medyo mabagal siya. At nung going to the left, medyo napabilis kasi natulungan siya ng wind. Okay? So, that's how we analyze the problem. That is speed and average velocity. Pero meron naman tayong tinatawag na instantaneous velocity. Ano naman itong instantaneous velocity? From the term itself, instantaneous or instant, the instantaneous velocity indicates how fast the car moves in the direction of motion at each instant of time. Kung baga doon sa moment na yon. Kasi halimbawa, meron kang velocity. Like for example, you are riding a motorcycle. If you have a motorcycle, you ride the motorcycle, your motorcycle from home going to school. Ngayon, pwede mong sabihin na ang takbo mo, for example, from your home going to school is 40 kilometers per hour. That is just the average, 40 kilometers per hour. But that doesn't give you the information na, for example, 10 seconds after kang umandar, ilan na yung velocity mo? Or 10 minutes after nung umaandar ka na, ano yung velocity mo during that time habang tumatakbo ka? So during that instant of time, if we want to get the velocity, ang tawag natin doon ay instantaneous velocity. Kasi iba-iba yon. Siyempre, mula bahay hanggang school, kung nagda-drive ka, hindi naman constant ang velocity mo. Kasi minsan, mabilis ka kung wala masyadong sasakyan. Kung medyo maraming sasakyan, babagal ka. So, hindi constant yon. Kanina, dinescribe lang natin siya, average from home to school. But then again, if you want to get at any instant of time during that period, okay, that is what we call instantaneous velocity. Kaya nga itong instantaneous velocity, this is just equal to your delta x over delta t. Ito yung equation natin kanina. But then, meron siyang limit, where this limit as delta t approaches to 0, but not 0. Okay, no? As delta t approaches to 0, but not equal to 0. Kasi kung pag nag-0 na ang time, ibig sabihin, nag-stop na yan. Ibig sabihin, doon lang sa pinaka-instant na yon. Minsan yung sinasabi natin na split second. Halimbawa, nagka-travel ka from point A to point B. Okay? Ngayon gusto mong kunin yung velocity dito sa point na to habang umaandar ka. Okay? So kunin mo yung velocity, yung distance na yon na na-cover mo at that very split second, no? Kaya nga as delta t approaches to 0, but not 0. Again, but not 0. As t just approaches to 0. Okay, that is the instantaneous velocity. Okay. So, acceleration naman. The notion of acceleration emerges when a change in velocity is combined with the time during which the change occurs. Again, acceleration emerges when a change in velocity is combined with the time during which the change occurs. Okay? So, tandaan niyo yan, change in velocity. Kapag walang change ng velocity, therefore, walang acceleration. Nagkakaroon ng acceleration kapag nag-change ang velocity. Pag sinabing velocity, it's either the magnitude or the direction changes. Okay, imagine, again, balik tayo doon sa sample natin ng motorcycle. For example, again, you are riding your motorcycle. For example, you are traveling with a velocity of 40 kilometers per hour. Kaso, gusto mong medyo bilis-bilisan kasi malilate ka na. Ngayon, tumapak ka ngayon doon sa gear. Or kaya, mas pinihit mo yung, anong tawag natin doon? Yung silinyador. Para mas bumilis ka. So, gusto mo from 40 kilometers per hour, ang maging takbo mo ay 60 kilometers per hour. Okay, so, like for example, for the sake of illustration, gawin kong meters per second ang ating unit. Like for example, initial velocity mo ay 40 meters per second. Kaso, gusto mong bilis-bilisan para ang maging velocity mo ay 60 meters per second. So, para mas bumilis ka, syempre, of course, yun nga, mag-i-increase ka ng gear. pag increase mo ba ng gear, automatically from 40, 60 ka kaagad on a split second? Siyempre hindi. Kasi kung mangyayari yon na 40 meters per second to 60 meters per second on a split second, malamang gas-gas ang aabutin mo, tatalsik ka niyan sa motor. Tama ba? Buti kung gas-gas lang. Okay? So, hindi siya ganun. Ibig sabihin, merong gradual lang, paunti-unti lang yung pag-change mo from 40 to 60. Sabihin natin na nag-change ka, yung time mo from 40 to 60 ay after 5 seconds. Paunti-unti. Okay? So, ito yung time during which the change occurs. Itong time na yan. Ibig sabihin, ito na yung delta T mo. Okay? Yun na yung naging change of time. From 40 to 60 meters per second, yung naging change of time mo din during that time, or the period, or the elapsed time na nag-take effect yung change is 5 seconds. Now, we can compute for the acceleration. Paano? Okay, so this is now our acceleration equation. Our acceleration equation is acceleration is v, the final velocity, minus v sub o, the initial velocity, over t minus t sub o. Or this is change in velocity over change in time. Okay? So, ito nga, change in time na itong 5 seconds. Now, if we are to compute for the acceleration of our illustration, if you're riding a bicycle, you want to increase your velocity from 40 meters per second to 60 meters per second. If we are to compute for your acceleration, acceleration is equal to v minus v sub o all over t minus t sub o. Or this is just equal to v minus v sub o over your delta t, the elapsed time. Dito binigay na 5 seconds. Okay, in other book, makita nyo, ang v final is vf, ang v sub o or ang initial ay vi. Wala namang problema as long as maging consistent ka ng iyong mga variables. Okay, so dito, ang final velocity ay v. Okay, so v is 60 meters per second minus v sub o, the initial is 40 meters per second. All over the elapsed time, delta t, 5 seconds. Now, let me just highlight this one. So, 60 meters per second minus 40 meters per second, this is 20 meters per second divided by 5 seconds. Okay, so 20 meters per second divided by 5 seconds, this is 4. So what will now be our unit for acceleration? Our unit for acceleration is meters per second squared. So the acceleration is 4 meters per second squared. Or kaya, coming from this is meter per second per second. So that just mean that acceleration is the change in speed. Again, balik tayo dito sa ating illustration from 40 to 60 meters per second. Sabihin natin, ito yung point A ko, yung starting point ko. Yung velocity initial ay 40 meters per second. Then, to point B, the velocity is 60 meters per second. Ngayon, nag-take effect ito in 5 seconds. Sabihin natin 1, 2, 3, 4, 5. Sabihin natin yan yung 5 seconds na lang. Ito ay 1, 2, 3, 4, 5 seconds. Sabi dito, you are changing your velocity by 4 meter per second squared. Or ibig sabihin nito, nag-change ang velocity mo ng 4 meter per second per second. Okay? If we are to illustrate this on this timeline, like for example, from point A, after 1 second, ilan lang velocity mo? From the information of acceleration, sabi doon, after 1 second, dapat magdadagdag ka ng 4 meter per second. So, after 1 second, ilan na to? 44 meters per second. After 2 seconds, 48 meters per second. After 3 seconds, 52 meters per second. After another second, 56 meters per second. And during the 5-second mark, kung saan totally nakaabot ka na ng 60 plus 4, ito ngayon ay 60 meters per second. Your desired final velocity. So that is the concept of acceleration. Okay? So, for now, hanggang dyan muna tayo sa concept ng speed, velocity, and acceleration. I will post also a video lecture for the derivation of equations of kinematics for constant acceleration. So, I hope mas naintindihan nyo na yung concept dito sa kinematics with this video discussion. So, thank you so much. Hopefully, you continue to work on and review these lessons, yung mga modules and video lectures, and continue submitting on time with your assessment task. Thank you so much.